Hello everyone, so in this video we will be discussing about Wallis formula, and Wallis formula comes in this form or general form where we have a definite integral of sine raised to mx cosine raised to nx dx from 0 to pi over 2. So in that case, if we have the integrand, we have a definite integral of this form that is also said to be equivalent with our Wallis formula, which is m minus 1 multiplied by m minus 3 multiplied by m minus 5 until the result is either 1 or 2, and is also multiplied with n minus 1 multiplied by n minus 3 multiplied by n minus 5 up until the result is either 1 or 2, all over m plus n multiplied by m plus n minus 2 multiplied by m plus n minus 4 until the result of this one as well is either 1 or 2, and multiplied with our alpha, in which alpha is equivalent to pi over 2 if m and n are even integers, but if it's not an even integers, alpha is equivalent to 1.
For the first simple example we have is the integral of sine cubed x times cosine raised to 7 x dx from 0 up to pi over 2. The first thing that we are going to do is to identify the m, n, and the multiplier that we are going to use. So based from the formula, m is equal to the exponent of the first trigonometric function in the given, and in our scenario it is sine. Sine in here is raised to 3, therefore our m is equal to 3, while n is the exponent of the second trigonometric function, which is cosine. Cosine in here is raised to 7, so our n is equivalent to 7. Next, let's identify our multiplier alpha. Based on the formula, if m and n are both even number, then the multiplier would be pi over 2. Otherwise, the multiplier is 1. As we can see, both of our m and n are odd numbers and not even, so our multiplier will be equal to 1. Now, let's plug in all the given numbers to the formula. For our numerator, we are going to deduct ascending odd numbers from n and n, then we'll multiply all the results. So our m is equal to 3. So 3 minus 1. We'll only do it until m minus 1 because 3 minus 1 is already equal to 2. And it says in the formula that we continue deducting until the result is equal to 2 or more. Okay, next, our n is equal to 7. So 3 minus 1 multiplied by 7 minus 1 times 7 minus 3 times 7 minus 5. Again, we'll only deduct 7 until 5 only, since its result is equal to 2 already. For our denominator, we'll deduct ascending even numbers from the sum of m and n until we reach the result of 1 or 2. m plus n, which is 3 plus 7 times 3 plus 7 minus 2 multiplied by 3 plus 7 minus 4 multiplied by 3 plus 7 minus 6 multiplied by 3 plus 7 minus 8. Now, let's do the operation. 3 minus 1 is equal to 2 times 7 minus 1, which is 6, times 7 minus 3, which is 4, times 7 minus 5, which is 2, all over 3 plus 7, which is 10, times 3 plus 7 minus 2, which is 8, times 3 plus 7 minus 4, which is 6, times 3 plus 7 minus 6, which is 4, and 3 plus 7 minus 8, which is 2. Let's cancel all the numbers that we can cancel first before doing the next operation. Now, we only have 1 over 5 times 8. So, our final answer is 1 over 40. The integral of sine cube x times cosine raised to 7x dx from 0 up to pi over 2 is equal to 1 over 40.
So I will be giving the example for uneven integers. I have here an equation which is definite integral of 0 to pi over 2 cosecant 8x cosine squared x dx, where our m is equals to 8 and n is equals to 2. I will evaluate this using this formula, which is the Wallis formula, by substituting all the given. Our m is equals to 3. So let's substitute the 8 to our m. 8 minus 1 times 8 minus 3 times 8 minus 5 times 8 minus 7. I stop at 7 because our difference will be equals to 1. So let's go on to the end, which is 2 minus 1. Again, I stop here at 1 because our difference will be equals to 1. All over m plus n, which is 8 plus 2 times 8 plus 2 minus 2 and multiply by 8 plus 2 minus 4, 8 plus 2 minus 6, and 8 plus 2 minus 8. I stop here at 8 because our difference will be going to equals to 2. Pi over 2. Pi over 2 because this is an even integers. So let's calculate this. 8 plus 1 is equals to 7 times 8 minus 3 is equals to 5, and 8 minus 5 is equals to 3. 8 minus 7 is equals to 1 times 2 minus 1 is equals to 1 over the denominator, which is 8 plus 2 equals to 10. 10 minus 2 is equals to 8. 10 minus 4 is equals to 6. 10 minus 2, 10 minus 6 is equals to 4, and 10 minus 8 is equals to 2. Multiplied by pi over 2. Let's cancel, that is needed to be cancelled. 10 and 5, 2. 3 and 6, 2. So let us solve the numerator, which is 7 times 1 is equals to 7 times pi is equals to 7 pi. And all over the denominator, which is 2 times 8 is equals to 16 times 2 is equals to 32 times 4 is equals to 128 times 2 is equals to 256 and times 2 is equals to 512. And this is our final answer.
For third example, the definite integral of cos raised to 8 3 theta d theta from 0 to pi over 6. As you can see, our limit is not 0 to pi over 2. So, meaning to say, we need to transform our limit to make it as 0 to pi over 2. So, we have the integral of 0 to pi over 2 sine raised to m x cos raised to n x dx. So, meaning to say, our 3 theta here, we can let that as 1 as our x. So, 3 theta is equal to x. And to transform our limit, we can substitute our upper limits in our original limits to our theta here. So, for upper limit, we can have x is equal to 3 times pi over 6, which is 3 divided by 6, that is pi over 2. So, it is okay. So, for lower limit, x is equal to 3 times 0. So, x is equal to 0. So, it is okay. So, meaning to say, we have our new transform limits. So, now, we just have to find the derivative of this one so that we can replace it here. Now, dx is equal to 3 d theta. To isolate the d theta, we have to divide it both sides by 3 to cancel the 3 right here. So, dx over 3 is equal to d theta, which we can write into d theta is equal to 1/3 dx. So, meaning to say, we can already transform this one at 0 to pi over 2. So, the integral of 0 to pi over 2 cos raised to 8 x dx over 3. Now, 1/3 here is constant, so we can put it outside. 1/3 integral of 0 to pi over 2 cos raised to 8 x dx. As you can see, there are no sign right here. So, m is 0 while n is 8 right here. As you can see, 8 is even. So, we multiply the answer by pi over 2. So, using the Wallis formula, 1/3 times the m, which is 0, we can let 1 as m. And 8 minus 1, 8 minus 3, multiply by 8 minus 5, multiply by 8 minus 7. Since the answer is 1, we can stop right here. All over m plus n, which is 8. Which multiply by 8 minus 2, multiply by 8 minus 4, multiply by 8 minus 6. The answer is 2. We can stop right here. Multiply by pi over 2. So, equal 1/3. Copy the m, 1, 8 multiply by 7 multiply by 5 by 3 by 1 all over 8 multiply by 6 by 4 by 2 and multiply by pi over 2. The 3 right here, so that 7 times 5 is 35 pi. So 8 times 6 times 4 times 2 is equal to 768. So this is the final answer.
Hello everyone, I am Camille Mae B Alimangohan from CE IT02201A. The first semester have been a huge struggle for my freshman life, and I thought that this is just something that I can overcome, but then I was wrong. I was excited when sem break came because at last I may now rest and be ready for the second semester. But again, I was wrong. Second semester came and it still feels wrong. It is hard to cope up with everything. It seems like I am adjusting with the system, but my body and mind can't take it. Our house isn't a good place to study, and academic tools are insufficient in here. Honestly, I don't know if I've learned anything from this semester, but I'm still doing the best that I can. I am hoping to proceed to my sophomore years by face-to-face system because that is where we belong.
Hi, this is Camila Antiporta from CIT02-01. Learning was a bit challenging, especially in this pandemic. The lack of experience and equipment in online learning took me a long time to cope up and balance time. I experienced changing places just to have a secured internet connection, doing household chores while listening and answering worksheets. Although we managed to make it this far, we are still rooting for a better education. This kind of pressure is something that we shouldn't experience. I still believe that we all deserve to learn the best way we can and bring back the motivation that was lost during this time.
Hi, I am Francesca Placido, sharing my experiences during online class. Online class is really tough for me because I am not only experiencing all about school problems but also the problem inside our house. There are times that I have online class and I have slow internet connection and it caused me not to follow what is being lectured in the online meeting. Alam ko namang hindi ko may iwasan, but I'm thankful because some of our teachers sends video about the lecture that is being discussed, so pwedeng mabalik ka lahat ng tinuro. Also, there are times na gusto ko mag-recite kaso ang ingay sa pinag-aaralan ko, so I cannot to recite and nawawala rin ako sa focus dahil sa ingay. There are times that some of our teachers is not teaching but give lots of school works that are needed to be passed. I have no choice not to study the subject and do all the works that is assigned to me kahit na may sakit na pero nagagawin, pero hindi ko pa rin may iwasan na gumawa ng mga gagawin kasi nga ayokong bumagsak and ayokong may mamiss na mga requirements na ipapasa. But I feel blessed because I can conquer this school year and it is all about our determination, but not our problems.
My online learning experience as a student is not so good. Mahirap ang online class dahil sa pakiramdam mo na natututo ka lang by your own at nahihirapan tayo kapag hindi natin maintindihan ang isang tanong or yung lesson. The only thing that I like is that I don't have to wake up early in the morning. Maganda ang online class dahil mas hawak mo ang oras mo. Wala nang masasayang na oras sa paglalaan sa biyahe o di kaya mga bakanting oras na nilalaan sa klase kapag ang guro ay hindi pumunta sa klase. Pero nawala rin yung mga kwentuhan sa loob ng silid-aralan. Being in a physical classroom makes me feel focused on my work. Pero sa online class, marami ang posibleng maging sagabal o maging dahilan upang hindi tayo maging prosigido sa pag-aaral pagdating sa usapan sa bahay. Maganda sana ang online learning, ngunit natututo na lamang tayo ng substantial facts at hindi ang magpakatao at matutunan na bumuo ng makabuluhang ugnayan sa ibang tao. Online learning is hard for me.
Hi, this is Julia Villegas from CEIT 02201A. If I were to describe my online learning experience this semester, to be honest, it is quite tough with the continuous adjustments of flexible learning, subject requirements, and difficulty of staying motivated due to a lot of distractions. But I won't lie that flexible learning has advantages of us having control with our time and also a way of avoiding strenuous commutes. But overall, this semester I managed to be productive, meet deadlines on time, and acquired a lot of information which for sure will be of great use to my chosen field.